Hi guys, this is Akash Verma and you're watching Cafe IO. Thank you for joining in. Currently, we do not have any participants, so we are just gonna wait for a while. Just doing a couple of testing, mic and video checkup. Hope things are well and correct. We will soon be starting at around 10 p.m. So let's just give a couple of minutes and we should be back. All right. Hmm. So I'm just gonna go on mute till there's somebody. There's quite literally nobody in the stream right now, so I'm just testing this out. Okay, I can see there are two people. Guys, thank you for joining in. Can you just throw in a quick comment and tell me if I'm audible and visible and all of that? Anybody? I do not know where you're participating from, but if you're on YouTube or if you're on Twitch or if you're on Facebook, all of that is great. So we are gonna go start talking about the key content in about 2-3 minutes from now. We'll start the stream sharp at 10, uh, and then we'll go from there. Just trying to check if I had any impact. Oh, okay. Okay, so we are at 9:58 and we will start the stream now. So the topic for today is how to do a system design, and the idea is relatively simple or complex depending on where you're from which perspective you're looking at, right? And some people are very natural, some people are trying to learn system design, and there's a lot of content on the internet that kind of teaches system design. The agenda for this topic or this stream is not to get into a lot of depth, but more so try and understand the nuances that are covered inside inside system design. What do we consider as system design, what really is a system, how do you understand that this is a system design problem. And if you are in an interview setup, if you're trying to appear for a job or something like that, you might be asked to design a system. It could be any system. It could be some a system of the like natures of LinkedIn, Quora, YouTube, any of these. And these are very popular system design questions which are asked, right? Or you could design a WhatsApp like a setup, or you could design a YouTube kind of a setup and things like that. So system design is a relatively vast topic, I would say. Comprises of a lot of different areas in technology. You need to be aware of a little bit of development. You need to be aware of design, a lot of infrastructure, and beyond all, I think a very high level approach, or I would say a systems approach to thinking, which really involves identifying the key modules, the key stuff that kind of makes and defines a system, and how are these different components connected, right? The closest example could be in an object oriented world, or in a simple three-tier architecture or any module based system. You try and study the behaviors of each module, and you try to understand how these modules talk amongst them. How do they exchange data? What are the methods which are used to exchange data? How is the data maybe secured? And those kind of things. So to set the agenda for the session, what we will talk about here is how do you understand requirement? How do you lay down assumptions? And these are the two starting pillars for any system design conversation, right? And we'll take a slightly more deeper dive into that. Then we are go on to Then we will go on to look at a single server setup. How does it look? How does a simple single server setup looks, which is where you have one application, a front end and a back end maybe. And then we'll slowly extend that. We'll probably add a database. We'll probably add a basic three-tier architecture. We'll talk about DNS concepts, and then slowly and eventually we'll add more scale to it, right? Once you have established a baseline where you have a standard three-tier architecture, we could then probably move on to understanding how do we work with scale. Hey, hi guys, I can see that people are dropping in. We are just beginning to start. I'm just trying to establish the agenda for the session. So if you have any specific questions about system design, feel free to drop in. And once we have established the baseline with a standard three-tier architecture, then we'll go on to talk scale. Then we'll do a load balancer. We'll talk about DNSs. We'll talk about caches. And we'll probably also understand what really is scale, right? Because a lot of times we talk about scale, and but what leads to scale, right? What are the challenges that you can encounter when you deal with something at scale? And then finally, what I'm going to do is there's a lot of engineering blogs that I read, and it's impossible for me to kind of refer all of that. So I'm just going to copy them and put it in the somewhere in the description after the stream is over, so that you guys can take a good look at that. And that's the core agenda for the day, right? For the conversation. So let's get started. Let's get started with the core aspect of it. Anyone, any queries so far? Anything that you want to ask before we begin? Any starting points that you have? Because this is going to be more of a conversation rather than a unidirectional flow of information, right? I want to keep it interactive. So feel free to drop in your thoughts in the chat, and then we'll try to address that. All right. So here's a simple notepad that I have, and I hope this is visible to everyone. And we'll start. So we are going to be talking of system design, right? And the first thing that we do when we define a system is how do we define it, right? What is a system, and more so, what is a software system? And my perspective of this is a software system is a collection of different functions or operations that are working seamlessly, right? And it's very logical, and it's a very abstract definition. uh, I wouldn't consider it to be any sort of academically correct discussion also. So if I just stick to my definition, if there is a user uh, who is accessing a mobile application, uh, and there's some text on it, and this mobile application is talking to a, let's say, server. This is a system. This is a good enough system, right? uh, Alternatively, if there's a user which is just consuming a SaaS product, right? This is also a system, like, but maybe this is a subsystem, right? So, and maybe this SaaS website is doing this, and a lot of different connections could exist, unidirectional, bidirectional. So this is a subsystem again. Now, people who formally study this art or science, there's very deep meaning to the way we make these boxes and arrows, right? For example, a lot of times boxes and arrows are probably just represented and thought as modules or something like that. However, the emphasis at which something works, right? For example, if this is a strong line, it is a bidirectional line, this is a circle. Each of the different structure could have a meaning, right? And let's say there's a decision tree. So the way you represent system is also extremely important. So the first thing when we start studying system design is you need to understand the way to study the system, the way to depict a system. Now, all of us in our academics have studied something called as UML, which stands for Unified Modeling Language, and it gives a standard vocabulary for us to define systems. It kind of helps us to define what shape usually corresponds to what. And then there's different kinds of diagrams that are used to depict different kind of activities. For example, you might have a class diagram, you might have an activity diagram, which is a much lower level construct. If you go much higher up, there's another beautiful modeling language which is called Archimate. Now, Archimate is a higher language, so as to say it has helped to model business processes, and it has helped to model a lot of different kinds of larger enterprise setup, more so towards business architecture and capability modeling. Not something in that we are going to be talking about, but just wanted you to know. So the core of the thing that we should start by understanding is building a strong vocabulary, right? Now, what do we do after this? Once we have vocabulary, right, it makes a relatively easy conversation to depict thoughts, because I, as well as the person whom I'm talking to, speaks the same language. It's like speaking a native language or speaking English, which is more of a common language, right? So the common language or the common lingo is extremely important in an organization if you're trying to talk systems. Now let's address this in a different tangent. How do we understand requirements really, right? If given a setup for, let's say, you need to design LinkedIn, what do we begin with, right? What do we try to think about? How do you go? Because it's a mammoth system. One of the key aspects of building such systems at scale is not to be boggled down. Because when people look at such a large scale and they think, oh my God, this is a relatively such a huge system, how am I going to do it? The first thing is nobody really expects you to, right? In an interview, the whole idea is to understand your thinking process and understand how you approach the problem. More so, not so much important as the correctness of the design. I would not say that you should just lay out any design, but the process and the assumptions and the way you collect is much more important. So, how do we capture requirements? Right? Requirements are of two types. One is called functional, the other is called non-functional. So we'll just put functional, and the other is non-functional. Now, functional requirement are system, what the system does. Right? This is what is a functional requirement. For example, LinkedIn is supposed to be a social network. It is supposed to help out people in a certain way. It is supposed to help people create content, create posts, build networks, find jobs. All of these are examples of functions. What is a non-functional requirement? Now, this is the interesting part, which is what needs to be focused on in a system design one. And this is what most of the architects are also worried about, right? I would not so worried about, but more so they are probably they kind of own this space, right? So what is non-functional requirement? These are, roughly speaking, quality requirements of the system, right? So usual trend is ET requirements, which is like uh, observability, speed, performance, these kind of requirements, right? And some of the common non-functional requirements could be performance, and then you need to define a scale for it. What unit are we talking? Then you can probably be trying to deal with volume, how much volume, and those sort of stuff that we are having to that we are doing. And then there could be more a different nature of non-functional requirements, which could be even related to compliances, could be related to statutory needs, or it could be related to structure, whatever. There could be a lot of non-functional requirements to worry about, right? So that's effectively non-functional requirement, all right? Now, given the nature of the problems that we can deal with, for instance, you're working towards a web application, or you're working off a mobile application, or you're working for an enterprise level application, or maybe you're working for a more of an integration project, machine learning, big data. All of them would have their own non-functional. Non-functionals are, well, some of them are common, but one of the equality requirements for an AI ML system could be the training time, right? Which is really not found in other type of systems. The machine learning training time, the model training time, that's really, really crucial. So trying to understand and separate the functional and non-functional is very important. So let's just start with LinkedIn. All right, what we talked about, and we're just sorry, my handwriting is relatively bad today. Not today, it's generally bad. LinkedIn. So what is it that the user is expected to do? I would say, let's say that let's try to ballpark the number of users, right? Let's say probably 1 million user. I'm just going to keep it down. It could be a billion or so. Then what is the number of concurrent users? Let's say maybe, I don't know, 1000 users per second or at the same time. All right. What is the latency requirement? Maybe we can say 5 ms maximum, 5 millisecond. And I'm just laying it out. The actual number is not so much important. It should not be preposterous, like I shouldn't write probably minutes for a transactional system. All right. What else could be there, right? We are capturing very high data, but the individual payload is probably going to be relatively small. Let's just say, I don't know, maybe 100 KB. All right, just for ease of math. Another thing to remember, if you're in an interview scenario, it's better to take 500s and thousands and do ballpark estimation. This technique is called, well, back of hand estimation. You need not be accurate, but the speed is important, because this allows me that if there are 1000 users every second, and each payload is, let's say, 100 KB, and let's say one user is probably doing, I don't know, 10 calls every second. So every second, one user is giving me somewhere around 1 MB of data, right? And this is 5 milliseconds. So that's another parameter we got to figure out how to solve around. But the key aspect is trying to arrive at numbers like this. Then we can probably try to calculate volume. If there's 1 MB per user per second, for 1000 users, it will be like 1000 MBs per second. So we are talking about GB per second, right? And that's huge data, right? That's huge data. What else could be there? And we can then see how much storage LinkedIn needs. So every second it's getting a GB. 1 second, 1 GB. In a minute, it's 60 GB into 24, right? And this is a very high number. Like, you're talking of petabytes of data generated every day, which is probably not correct. I'm just laying out some thoughts. And then After doing some of these precarious math, you end up with some kind of a storage number. Let's just say it's 1000 GB per day is what you ingest. All right. Then there's a couple of other things to worry about. What are they, right? You need to probably pay a relatively strong attention to how you're securing your stuff, right? Security is of importance. How do you make sure that, let's say this is the map of the world, there's a user sitting here and there's a data center sitting here. How do you get the data there? You can't have all the data physically close to all the users, right? So that's another set of challenge. So how do we solve for, let's say, location? And this is another non-functional requirement, right? I'm just trying to lay out non-functionals as I go along. What more could we do, right? We have talked about number of users. We have talked about speed of operation. We have looked at storage. We have looked at security. We have probably looked at geography. What else could be there? Yeah, disaster recovery, right? Disaster recovery, important point to worry about, right? And again, these are things that you can use to talk about and impress the interviewer or whomsoever you're talking to, right? Let's say high availability, and these are just words, but these have to be quantified, right? For example, three duplications uh, up in 15 seconds, right? You can define numbers like these. And what these are really numbers which are quality attributes of the system. Now, once you have this, right, then you go to shop. Effectively, what I'm trying to say is that once you have identified your needs, for example, I'm in the market for buying a computer, I'm gonna lay out all of my needs. I would be stupid if I just try to go and say, hey, give me a computer. What should it do? Everything. That's usually going to end up costing more. And this conversation is more of a discussion with the person you're talking to, or in general, when you're if you're designing yourself. So a very strong attention to NFRs is extremely important to learn. And these are your bread and butter if you're trying to design systems for, well, a living. What do we have next after that, right? So you have defined the requirements, the way you have defined the requirements, and you have listed down some assumptions, right? In a practical setup, in a real world scenario, let's say you do not are in an interview setup, then you don't lay out these assumptions. You try and figure out them by looking at the system. For example, you challenge your team to do a load and performance testing, and you try and understand some of the numbers that the system is getting. And then you use estimation, or you do extrapolation of that data to be able to arrive at some detail. All right. Let's move on. Right. So how does a single server setup work? Right. How would a straightforward or a single web application work? Well, there will be a user which will have some kind of, let's say, a web app or a mobile application, and it is connected to some kind of server, and that's it. That's really it. If I want to increase more of this is a great example of having a WordPress site, right? I could probably just build a WordPress site with this. And there's another interesting concept called DNS, which is domain name service, which probably is something like DNS. And you first actually go to your DNS, which is your first call, and then your DNS is gonna just come back to, and it will give you some sort of an IP, because the DNSs would know where to route this, and there are more deeper constructs, and then the call would just probably go back here, and on the way back to 4 to the user, right? So user gets it at 4. This is just very simple, I would say, request response based. a relatively simple single server architecture. There's nothing fancy about this. This is very common now. So if you're probably gonna check out a static website or anything like that, this is what you're gonna get. Now these servers are typically web servers, which is I would, at the risk of sounding too simple, I would go on to say that these are relatively simpler servers where you don't have to kind of have a lot of logic, and it's more delivering static stuff, right? Now this thing becomes a relatively more complex. We will probably, I don't know how to take a snapshot here, but then we'll draw it again. So there was a user, there's DNS, there's web server, right? Now if we add another deeper layer, which is like app server, and we add a DB, this becomes a relatively heavy three-tier architecture. So again, this is 1 and 2, then you go for a call 3, then you do 4, then you do 5, on your way back 6, 7, 8. So there's a traffic is just routed through the setup, right? And this is a more of a modern web application, or a more standard setup for a web application, where you have some kind of a database, some kind of a web server, and uh, a relative setup which connects all of these things. Now this is what you would call a system, and in the very basic sense, this is a system which all of you should master and understand and start with, right? No load balancers, no fancy stuff, just basic three-tier architecture, right? Now this is also called MVC, model view controller, different frameworks, different styles, but we can just stick with a three-tier or layered architecture for that matter, right? And more layers can come in the architecture, but this is the a basic setup. Now, if we want to scale it, is this of LinkedIn level? Not at all. This cannot handle the load that LinkedIn throws at it. This is at best some sort of a well document management system, or a small web app, right? Now, if we want to do scaling of it, right, we need to understand the whole construct of scaling before we start talking of scaling technologies. And I'm not going to go deep into any of the technologies. That's probably for future streams. To do drop in your comments if you guys want to learn more about it. But how do we get to scale, right? What leads to scale? Now there are two kinds of scenarios where which could cause scale, right? One, and we are talking modern web applications, and other systems would have other parameters. But the most common culprits are users. The number of users increases, which results in larger number of transaction, which increases the pressure on the systems. The other is data, which is also a function of user. However, a lot of times you could be just capturing data from different sources. For example, and I think this goes back to an old joke which we had internally is, how much time does it take to design a simple page with one form in it? Probably half a day. But there's also a company called Google which just has that as an interface, right? So the whole idea is that Google has a lot of user traffic also, but even if you did not have user traffic, you could be getting data from a different setup. For instance, you are collecting a lot of server logs, and your system is supposed to search and show you data from your servers. And in that scenario, your data growth is what is causing scale, not the number of users. So the non-functionals would change. They would not be typically of the nature of response times, performance, number of users, concurrent users. That just goes for a toss. They would be more of a nature of IOPS, memory intensive operations, how much memory you need, turnaround time, types of disks you have used, which could further influence IOPS and things like that. So bottom line is, what leads to scale is something that needs to be understood. Is it user? Is it data? And there could be other drivers as well, but in my opinion, these are the two ones. Yes, data is connected to users at times, but Data can itself be a standalone drivers. Users are more or less pretty widely understood why it would lead to growth, right? And for a web application or a mobile application, the number of users is a very easy parameter to understand, right? So how do we address this, right? How do we address scalability? Now, people use scalability can come in different form factors, in different ways. You could be talking of horizontal scaling or vertical scaling. Now, vertical scaling is scaling up, which is to say, you have a machine, you add more power, CPU, etc., to your server, and this is a great option if your traffic is low. If you're running with well, couple of hundreds of couple of thousands of users, vertical scaling is possible because you can add to it. However, a lot of times vertical scaling comes with really serious limitations because it has a hard limit, right? You cannot probably shoot up a machine beyond a threshold. And it is impossible to add an unlimited CPU and memory to a single server as well, right? So, to a key to understand, let's just summarize what I've talked about. So we are talking of scale, and we are talking of vertical scale or horizontal scale, right? And both of them are popular. It's not that one is bad or the other is good. However, vertical scaling is not really a great idea to do if you are going into a use case like LinkedIn. So the key thing you will want to understand is there's no failover, there's no redundancy, there's a hard limit. So you kind of have to go for horizontal scaling, which is what most modern web applications do. They try to do distributed route, and you just add more servers to it. And that's where your most modern web application designs like web services and all kind of just steal the show, right? What else could you do if you have a, let's say, let's just take our design and move forward. So we had a user, we wanted to have a server, right? Now we have, let's say, a web server for static stuff, and then what we do is we add a load balancer which routes to different servers. Now this load balancer helps in routing, and load balancers are one of the most commonly used techniques for helping scale. You could add a load balancer on top of, let's say, app server. If there's a database, you could have a distributed database, and then there could be an LB sitting here, which these app servers are connecting through, and there could be replication in between. There's more strategies you can do. For example, creating read replicas, or creating write only databases and read only databases. And that's more database level load balancing. So load balancing is a strategy which you bring in, which helps you balance out a lot of uh, when you have to work with distributed setups, right? So when you have a horizontal scaling scenario, you add load balancers because there's multiple servers who can balance the load, right? And that's a very important concept to know when you're talking scale, right? Next, and this kind of helps us, load balancers kind of helps us bring and dissipate more scale, right? Another popular technology which is there and I want to talk about is, for example, this is user and this is a web server, right? If this was a geographically distributed problem, it would be relatively difficult, and the latency is very difficult to manage because you cannot be physically placing your web servers across the globe. So there's a very sweet stuff, which is more like a cache, and we'll talk about cache after this. That is called CDN, which is called Content Delivery Network. And most of the times, without even realizing you are using this, the world quite literally runs off CDNs. And CDNs are one of the greatest or most fragmented or most, uh, I love them. They are one of the best pieces of technology because when I access a website, they are the one making sure that most of the static information and most of the key stuff is delivered right from my local location. So There's a lot of popular vendors. Akamai, AWS has its own CDN, Azure has CDN. There's a couple of other players on the market. But CDNs are great and versatile tools to quickly scale your applications to close users. For example, when you're watching a YouTube video or LinkedIn and you're accessing a lot of content, the content creation game quite literally relies on CDNs, because it is impossible for YouTube to send you a video from North America to probably somewhere in India, right? And the buffering time, let's just say, is going to be very high. So CDNs help you achieve that. Most of the static information, things like fonts, images, icons, pictures, they are also cached in CDNs. So CDNs are pretty much uh, storage locations, caches, whatever we want to call them, and then there are ways to manage CDNs and work with CDNs that could help you guys or help people just go more scale. So this solves the or previous couple of problems of where we listed down location, right? This problem. So just taking a summary, we have talked about location. Storage could be probably handled by database and database level load balancing, though this is high throughput. And we are going to be talking of users also. Now, some of these user requirements could also be sorted by what do we say, CDNs, right? So we are going to go and look at more detailed and more elaborate architecture. Right now, we have a good setup. We have a CDN, we have a cache, we have a sorry, we don't have a cache yet. We have a load balancer, but we are going to be talking about caches now. All right, so just going to draw again. So my favorite user, CDN, web server, LB, app server, LB, DB. All right, and that's the path. Now, caches are another piece of technology which you can rely on at every level, and these could further help you improve your game of delivering stuff, right? So, if there's a cache sitting here, and you can technically have a cache at DB level also, there's a database level cache, there's an application level cache, there's a web server level cache. Now, caches are typically things which are just temporary memory, right? Think of them as sticky notes. Uh, you want to refer them for some time, quick information, and once you're done, you're done. You want to just recycle them, right? So caches are a very important piece of technology which effectively help around getting information which is frequently accessed in a fast medium. Instead of putting it on a disk, keep it on memory. So in-memory caches are very popular. Things like Redis, key value pairs like Redis or Memcache, where you can just have an application server query a cache instead of a database. And this improves your response time tremendously. Now, a key thing to notice in a design more at a philosophical level is you are trying to minimize pushing things to disks and trying to serve information a more closely and have multiple copies of the same thing. This is what is something that helps enable scale. So yes, a lot of times you imagine that duplication is not a great idea, but effectively what you are doing is duplicating, but in a relatively different fashion. Caches are not persistent storage. Cache is, well, cache. It's going to be cleared out once your use case is sorted, right? So you can have cache at all levels. You can have cache at web server levels. You can have cache at database levels. You can have cache at application server levels and things like that. Cache management is a challenge in itself, which is something that we are not going to be talking about today. A couple of other use cases or scenarios which helps here, right? And I'm just going to lay out the technologies that I think are good enough. It's pretty crucial and it's pretty important to talk about what do we say, things like queues, or probably things like PubSub, different sort of methodology, things like Kafka, which kind of help you understand and queue your requests. So if web server is throttled, these are the systems which can just hold off for some time where your system kind of acts. So queues are also very important part of the whole setup. So overall, if you see a sample web application architecture, there's a lot of technologies that we have just talked about. This is probably a good summary. So you have a user, there's a CDN, there's a web server, cache, load balancer, application server, cache, again load balancer, DB, and then cache. At a database level, you could be having a lot of different stuff. You could be talking about master slave replication, read replica, primary databases, secondary databases, and all that, which again help boost the database performances, right? So that's effectively how you approach a system design problem. Just trying to conclude in the next 2 minutes that we started with the system. The key thing to do is start and understand probably let's just hide this. We don't know. We don't need it anymore. The key aspects would be a you understand the requirements, right? Where you have listed down the system, the problem, the functional, non-functional, right? Then you kind of list down the assumptions, which is the non-functionals, and then you work your way deeper into the problem layer by layer. If you are solving a large problem like LinkedIn, it would not be a great idea to take the system as a whole. Instead, probably take a part of the system, let's just say activity feed, or how to create a post, and design services around it. That could give you a lot of good insights around it. So that's the core thing which I wanted to talk about. I would highly recommend Mr. Gaurav Sen. I've myself used some of his videos. He talks really good, and he has covered a lot of these topics in an enormous depth. So do check out his YouTube channel, and there's another channel which I've been following for some time called Pseudocode. That's also good. You guys can check that out where those guys are talking the same stuff, similar stuff, but not the same. This channel is not really intended for system design. However, I kind of realized that a lot of people want to listen in on it, and this is an interesting topic to talk about, right? So with that, thank you for watching. Thank you for listening me. Bye bye. Have a good day, guys.